Anytime. Go
Oh,
ahead, sir.
hi, I'm Raywat Deonandan. I'm a professor and epidemiologist with the Interdisciplinary School of Health Sciences at the University of Ottawa. I'm a global health epidemiologist, which means that I look at the burden, causes, transmission of a variety of diseases at the population level around the world. And for the past few years, I've been focused on explaining to people how COVID-19 and the vaccines work and overall public health communication stuff.
And we want to get to that in a few moments, but I also want to talk to you, Raywad, about the technology involved in this and mRNA technology that helped develop vaccines for COVID and how that is now being used to solve other problems. First of all, what is mRNA technology?
Right. So traditional vaccines have taken either the actual thing that makes you sick and introduced it to your body to say, hey, look at this. Don't let this in. Or it's taken a piece of that thing that made you sick and said, hey, look at this. Don't let this in either. With mRNA, it's kind of like telling your body to make the thing to look out for. So if you think about, you can tell people, be on the lookout for a car with this license plate, and go door to door and tell them, or you can actually, email them a picture of the license plate. Say, hey, print this out, put it on your front door, and if you see this car going by, call the cops. Don't let them in. That's really what the mRNA technology is. It's telling your body to make the thing that you should be wary of, and it makes a safe version of that thing. So with COVID, we made the spike protein. So that's a little protein on the outside of the virus, and so your body makes it, and your cells say, "Hey, look, if we see this again, don't let it in." And so when the actual COVID virus comes in, we recognize a spike protein and we don't let it in. So that's like the really simple version of how this works. And people are always afraid that mRNA it's part of our genetic system. So is it a kind of gene therapy? No, it isn't. It does not interact with your DNA at all. It's downstream from the DNA encoding process. It's quite revolutionary. The beauty of it is that we can produce it faster and we can tailor make it more specifically for a variety of pathogens. In theory, it's still, of course, evolving and it's getting better and better with every iteration. The technology is.
What sort of things are we doing now and into 2025 where this conversation then takes it to the next level that we're starting to solve diseases like cancer?
Look, there's a really impressive vaccine out there right now made by Moderna and Merck called mRNA 4157. And it's showing like a 62% reduction in death after 3 years of after injection for patients with melanoma and lung cancer. There have been attempts to make cancer vaccines for a while now. We've got an HPV vaccine, which is fantastic for reducing the risk of cervical cancer and other kinds of related cancers. With mRNA, we can target a whole new set of different kinds of cancers. So a flotilla of new vaccines are being trialed at the moment for a variety of different kinds of cancers, including melanomas, as I mentioned, um, pancreatic cancers, colorectal cancers. All of those are starting human trials in 2025. They're not all mRNA based, but the age of immunotherapy is upon us.
And when we think about lung cancer, you've got a generation of people now that have been diagnosed with lung cancer and are going through a whole host of clinical trials to try to keep a generation of smokers alive.
Yeah, right. That's what it comes down to. But it's not just smokers. There's different causes of lung cancer. Lots of people, well, not lots, but many people get and suffer from lung cancer who never smoked a day in their life. Um, but yeah, that's what we're looking at. And really, for me, the most exciting part of this is really the dementia vaccines, right? Because to my mind, as a population scientist, the biggest threat, one of the biggest threats to our population is the aging population and the diseases that go along with aging. We're looking down the barrel at tremendous societal costs of aging diseases, in particular dementia. And we have very few treatment options and limited understanding of prevention. So the trialing of a variety of dementia vaccines is terribly exciting, both for prevention and for treatment.
What will be the determinant in 2025 as to whether or not these are going to be successful. I gather there is some history to this that suggests that, wait a minute, this has been a game changer. Why won't it be a game changer for dementia and cancer?
Well, different technologies are in play here and different diseases, so I think it's probably irresponsible of me to make projections for which will be successful and which won't. The HPV vaccines have been just phenomenally successful in keeping those cancers at bay. The initial data around the lung cancer and melanoma vaccines are really positive. On the other hand, the mRNA vaccine for preventing RSV in infants has taken a step back because the safety signals were problematic. So it's really hard to predict, right? There's a universal flu vaccine being developed on the mRNA platform, and that is transformative because a universal flu vaccine just removes the need to update the flu vaccine every year, and it may be longer lasting, and it applies to almost all of the candidates. And if we're looking at, potentially a pandemic of H5N1 bird flu, well, this technology becomes ever more preponderant, maybe even civilization saving. But your question is, how do we determine who the successes will be? Well, that's what clinical trials are for. So the way it works is we try it on animals first, then we do a safety test, and then there's a dosage test, and finally the overall efficacy trials. So right now, a lot of the cancer vaccines I talked about earlier are in the safety and dosage phases. When we get to the efficacy phases, then we're a whole new game.
With Raywat Deonandan ringing in the news year 2025 on 680 CJOB, Richard Kluche reporting. Then, of course, you spent a lot of your time explaining the safety around vaccines. And unfortunately, in 2025, we're going to have more of these conversations as a Trump administration comes in south of the border. How important is it that we look at the science and the data to dictate where we go on this?
It's, of course, very important. What's even more important is for people to understand what safe means. There is a large proportion of the population that thinks safe means perfectly safe. It does not. Everything involves risk. So you hear stories of this person, got seriously sick or even died from this vaccine, therefore it's not safe. That does happen. If tens of millions of people get shots, a handful are going to have bad reactions to it, and it's difficult to make things perfectly safe. So we need to educate the population about absolutes. Absolutes are probably not achievable at the population level. So when we say something is safe, it means for the overwhelming majority of people, it will be safe. And we try our best to identify that subpopulation who will have a bad reaction and have other options for those people. So I think the larger issue here is educating the population about what science is and what it can and can't do. Science is an evolving process, and we rank different kinds of data differently and different kinds of evidence differently. So a story coming from a doctor's office is important. It's not as important as preponderant mountains of data coming from a variety of collection depots around the world. And that's the challenge right now, is educating the population about the fundamentals of science, not just in whether data is good or bad.
How will artificial intelligence help in this entire process out, especially speeding up clinical trials and the development of vaccines?
It's very much a game changer. Now, at the bad end, AI is bad for misinformation, amplification. At the good end, at the scientific lab end of things, it's proving to be pretty good. So I've got a grad student in the past who used machine learning algorithms to develop a process for identifying cancerous cells under the microscope, for example. That's the kind of thing that will be well optimized and accelerated. There are reams of data that come out of multiple clinical trials that can be more quickly processed via AI. And that's just a couple of examples. AI can possibly even develop better vaccine candidates in theory that then go on to be tested. It can provide a kind of creativity that the individual human possibly cannot offer. And by creativity, I don't mean actual, human style artistry, but the ability to see patterns in data that we struggle to see. And that might be transformative.
I'm excited about 2025. I hope you are too.
Well, it's going to be interesting. That's for sure.
Raywat Deonandan, I appreciate the time and the insight as always.
It's my pleasure. Thank you.